So hello and welcome friends to our channel Intro Mech, where we discuss about basic mechanical engineering concepts and many other things which are related to industrial automation field. So guys, we have started our new series which is related to industrial robots, and in our previous sessions we learned about different configurations of the robots. So today we will be focusing on another configuration which is called as delta, a parallel or a spider robot. So without wasting time, let's get started. So what is a delta robot? So delta robot, sometimes also referred as a spider or parallel robots, are the robots with the base connected to jointed parallelograms. These parallelograms perform motions in a solitary end of arm tooling within the workspace that is dome shaped. So this type of robot is well known in the industrial field for its ability to execute minute precise motions. So here we can see it has a fixed base, and then the arms and the joints are there. So these form the parallelogram link, and these types of robots can work with more than 100 parts per minute. So that is how fast they are, and picking and placing and sorting them much faster than manual labor, and that's how make them special. So application, again we can see automated case packing, high precision assembly process, food processing, packaging, soldering. So these are kind of different applications in which they are widely used. So talking about the work envelope, so delta robots are known as parallel robots and consist of three arms which are connected to the common base. So you can see the common base and the arms. So they are designed for high speed and high precision pick and place task, and their work envelope resembles a dome. So here we can see, so delta robots have smaller work envelope compared to other robots, but they excel in the applications that require high precision, high speed in a confined space. So that makes them special. So even if they have restricted work envelope, but they can operate at very high speed. So here you can see the dome, how it forms. So that is nothing but its work envelope. So let's just type ABB. ABB is one of the leading manufacturer of the robots. Just go onto the page. So here we have products and solutions. We can go over there, and then we have robotics. So in robotics there will be different options available. So we can see the portfolio and the different industries and applications. So in the portfolio we have robots. In the robots we have articulated, collaborative, so many options. So we want a delta robot. So let's go to the delta robot. We have different options available depending on the payload and reach. So let's check out one of the robots. So this will they call it as a 360 flex speaker. We can read the key features. So again we can see high speed flexibility, high capacity, then hygienic design, superior tracking performance, integrated vision software. So these kind of features make them even more special. So let's try to find out the data sheet, and we can check more details about the delta robot. Let's open its data sheet. So here again we can read the different advantages. Now see, here is the specification, the version, the handling capacity, the diameter, number of axes, it has been mentioned over here. And then we have the conveyor tracking, so the constant conveyor, the speed they have given, and the repeatability, as we discussed, like they are used for pick and place. So in most of the cases they can be mounted over the conveyor and they can just pick and place, and that's how this tracking capability of conveyor speed matters. Then we can see the performance, the position, repeatability. We can check it's in 0.1 mm. Then again, cycle times, we can check for 0.1 kg, 1 kg, 3 kg, 6 kg. So depending on the mass, we can check out the cycle times. And then comes the working range, the envelope. So here again we can check the envelope, and they have given nodes depending on the version of the delta that will get changed. But as we saw, this is the work envelope for delta robots. So this is about the delta robot. We have seen its specifications. So let's check out the applications. So here we can see how fast it is picking and placing at the same time. If you could observe, it is sorting and it is placing. So the cycle time is like very fast. And then this is another pick and place application. So this is how you can see like how fast they can operate. So it's a very good solution. So this is how we have covered up till now all the different configurations of the robots which are widely used, and this is kind of a summary of whatever configurations we discussed. We started with the Cartesian configuration and we are now reached to the delta configuration. So if you consider the Cartesian robots, which are also called as a prismatic or linear robots, they can have maximum access 3 like XYZ. Their work envelope is a rectangular box shape. Common applications are 3D printing, we can place, and advantages is high precision programming. Limitations are bulky. Then we can move for cylindrical. The axis can be 3 or 4. The work envelope is cylinder, and common applications assembly, and you can check the advantages. Then spherical, again we have 3 and 4 axes. Then articulated robots can have more than 6 plus axes depending on the shape. Then we learned about SCARA robots in our previous session, and today we learned about the delta robots. So this is just a small quiz. Now here are different images on the left hand side. You can check the different images of the configurations. We have given the names A, B, C, D, and here the same but a schematic form with the motions has been mentioned. So let's pause the video and try to think which configuration suits which form and what is the name of the configuration. So let's pause the video, just think. So yeah, now we can check what is the A. So this is the articulated robot. We can see it is having joints with all the rotational and twisting motions. So this is A, which is articulated or jointed arm configuration. Then the B is a cylindrical configuration. We have this twist or rotation, and then these two linear axes. Then C is a SCARA. We have rotation, and vertical up and down motion. So that is nothing but the SCARA. And then we have the Cartesian configuration. So it can be X, Y, and Z. So that is X, Y, Z configuration. So these are the robot configurations. So this is it guys with our robot configurations. I hope in our previous sessions whatever we learned was just basics, but that will help you to know what is the basic terminology whenever you select the robot, what things need to be considered, and that is the main aim of these sessions. So if you have doubt regarding any of the configurations, you can drop a comment and we can discuss over there. Until then, Keep intro making. Thank you for your patient listening. Thank you.